Okay guys, so now that you know what exothermic and endothermic reactions are, now we're going to move on to graphs of exo and endothermic reactions. Right, so just remember, exothermic reactions release heat, so delta H will be negative or less than 0, and endothermic reactions absorbed or take in heat, so delta H is positive or greater than 0. Right, now the reason why we have all of this energy is because atoms, compounds, elements, anything that take part in the reaction, the reactants and products, they all have chemical potential energy. Now, if you remember, potential energy means the energy something has because of its position. Right, so if you're looking at, for example, this reaction here, can you see that you have reactants and then you have products, and they are all positioned differently. The reactants are positioned differently compared to the products, right? So for example, if you're looking at this compound CH4, can you see carbon is bonded to 4 hydrogens, and then here you have oxygen double bonded to each other. Now because they are in a certain position bonded to certain other elements, they have chemical potential energy. Right, and then when these same reactants now turn into products, those positions changes. So now carbon is no more bonded to hydrogen, it's bonded to oxygen with a double bond, and oxygen is no more bonded to another oxygen, it's now bonded to other hydrogens in water. So because their positions change, their chemical potential energy also changes. Right, so because potential energy is so important because of their positions, where they were as reactants and where they are now as products, we can draw potential energy graphs showing the difference in the potential energy of reactants compared to the potential energy of products. Now there's two graphs we're going to be looking at. The first type of graph is this graph on page 217. Can you see its potential energy versus cause of reaction? And then we have a different type of graph which is also a potential energy graph, and it looks more like this one here, like a curve. Now this graphs we're going to come back to later on, but we're going to first start with this graph. So you have ones that look like straight lines, and then you have ones that's a curve, and the curve one is actually more important to us, but we just need to see this one first. Right, so this graph is potential energy on the y-axis, course of reaction on the x-axis, and there's two of this graphs. One is for endothermic and one is for exothermic, but both is potential energy on the y-axis, course of reaction on the x-axis. Now you know, when you're doing a chemical reaction, you always start off with reactants, and then when the reaction happens, you turn into products. So reactants are first and then products are last. Reactants are the initial ones and products are the final ones. Now another word for reaction is reactants is reagents. So if you see reagents, just know it's just reactants. Okay, so if we're drawing this potential energy graph, we can see we have two types. We have one where it's decreasing and one where it's increasing. Now always when you're dealing with potential energy graphs, the ones that increase is always endothermic reaction, because remember endothermic reactions, the delta H always increases. That's why you have a positive value. And the ones where it's decreasing is always an exothermic reaction, because in exothermic delta H is negative and it's always decreasing. Right, so if we look at this graph, let's first start with this one here, which is decreasing. So since it's decreasing, it's an exothermic reaction. Now when I say decrease, I mean you're starting off at a higher number and then it's going down, and then you're ending off with a lower value or a lower graph. Okay, so it's always going down. It's starting off higher, going down, and then ending off lower. Now this one in the beginning is showing you the potential energy of the reactants. Then you have delta H happening here, which is during the reaction, the energy that's released. And then the end part is the product's potential energy. Now, because reagents is higher than products, it means that delta H will be negative, because remember delta H is products minus reactants. So if delta H is negative, it means that products is less than reactants, and we can see that from this graph. The products is lower, the reagents is higher, so that's why delta H is negative, and this is an exothermic reaction, which means you're releasing energy. And the amount of energy that you release can actually be you can actually get it from the graph. So whatever number of energy that you have here, there will be a value. Remember, it's a graph, so there will be values. Whatever value the reagents is and whatever value the products is, if you find the difference between the high point and the low point, that will give you delta H. Okay, and you always get a negative answer because it's an exothermic reaction. So just remember, exothermic reactions, the graph always decrease. You start off high and you end off low. Now, if you're looking at endothermic reaction, it's the opposite. You're starting off low and you're ending off high. So here, the reagents is the low part. Then delta H is increasing because you're absorbing energy. And then the products is a higher part. So if you have to work out delta H, which is energy of products minus energy of reactants, because the products are greater than the reactants, you will get a positive delta H. So delta H will be greater than 0, which shows it's an endothermic reaction and energy is absorbed from the environment. So the main thing you need to know about these graphs is that for exothermic, it always decreases, products is less than reactants. For endothermic, it always increases, products is more than reactants. And when we have ones with values, I'll show you how it actually works.